Hello, my name is Randy Boone, and in this video I'll be addressing a question that I have been asked, that is, why there are multiple versions of seemingly the same software. Why is there an L-range modeling family? And so I'll speak of G-range, L-range, AF-range, and it's true they are part of the same underlying code. Some changes, but they're modest. And really it comes down to the spatial scale at which a person is interested in working, and also whether an application is available or not. This way of looking at the world started with G-range. That was the first model put in place. The G in G-range is for global, and so it was a global rangeland model. And so when you look at that software, it is assuming that the world is the scale of the world. It's going from negative 180 degrees to positive 180 degrees, from negative 90 degrees south to positive 90 degrees north. It's assuming a globe. And so when you work on a global scale, that's perfectly appropriate. Things work out fine. If you're interested in working in a smaller area, you can use the software. So for example, if you're interested in modeling Kenya, say, you can turn off simulation of all the cells that aren't Kenya and still use the G-range model. But it really isn't as efficient as it could be. You're loading global maps and working in a smaller area. Recognizing that prompted me to create the L-range model, which again, just modest changes from the G-range model. If you knew and know how to use G-range, then you know how to use L-range. The L-range model is for a local area, so L for localized. When you provide surfaces to L-range, one of those surfaces, spatial surfaces, maps that are used to inform the model about the attributes of cells, one of those surfaces is used to learn about the area to be simulated as well. So instead of assuming it's the globe, it reads what should be simulated from one of those surfaces. L-range has been modified multiple times. The modifications have supported its connection to agent-based models. So L-range is the process-based ecosystem services model that was used in other settings to address questions about ecology, so to speak, and forage production and carbon sequestration and such. But to use the tool in a coupled systems approach, where we're representing humans and the ecosystems they rely upon, then we have agent-based models that connect with L-range. And so I've done this work with my large pastoral agent-based model, Dakuma. Rika Warrior, Dr. Warrior, is working on an application called Spiral that merges with L-range. And Melody Zaire is working on one with an application she calls Andes that works with L-range. These are agent-based models that represent people, and then the ecosystem services that are simulated in L-range inform the decision-making of the people, and then the people and their livestock help to modify the ecosystem services that are produced. So, for example, they distribute their animals on the landscape, and then that changes the ecosystem services that are generated. Lastly, there's a new application, Africa Range. It's not released just yet, but AF-range is an application to the continent of Africa. So in more detail then, G-range is a global model. And what has happened here? Now, this is an application that's approaching 10 years old now, perhaps 8 years old now. The paper was published in 2018, Boone et al. 2018. So it is an older application, but the software is the G-range software, a global representation, and candidate surfaces and parameters are included with that application for 15 biomes around the world. So the entire world is divided into 15 biomes that are then provided parameters that explain how vegetation grows in those areas. Now, they're not all behaving the same way. You wouldn't see the texture you see in this map if all the plants in those 15 biomes each behaved the same way as all the other plants did in a given biome. But there are also these spatial surfaces I speak of that make the attributes of individual landscape cells unique. And so although they have underlying parameters that are shared by all the other cells in a given biome, they follow different pathways through simulation. So a candidate application is in place. You can download GRange, run GRange, recognize again that you're using an older application. There could be changes that have taken place, certainly improved databases that are available, and hopefully updated someday. Right now, though, that hasn't happened, but you have an open invitation to modify the surfaces that are used, to modify the parameters that are used, and then improve the fit against assessed data. So if you simply swap out a surface, that might be inappropriate until the results are assessed. So certainly you can swap out a surface, but you should see what it does to the outcome and make sure that the model is still behaving reasonably. People have looked at the outcome from the paper of 2018, and it's held up okay so far, but it does make me nervous. So in short, you can download GRange, you can use it directly, and if you recognize its limitations, there's an application available, and it could be updated by someone who wanted to take a deeper dive. Then there's LRange. LRange, again, is the localized version of the software. Now, we speak of a rangeland model, and it certainly started out as a rangeland model, but LRange has been used to study forests in Kenya, for example, and is now forming part of the foundation for their looking at land cover change and tree forest cover change associated with a warming climate. So again, a local version, because it is a local version and appropriate for wherever you might want to work in the world, then there can't be an application for your area of interest unless you happen to be interested in the very specific area in which we have worked. Again, the scale can vary any way you wish. So it could represent a very large area. I've used LRange across a continent, or I've used it across a country, or it could be very small. I've also used it where the cells that represent the landscape are 300 meters across or 200 meters across. And so I distribute an example application with LRange. So I obviously can't distribute an application to your area of interest. That's the challenge that you take on, so to speak, by using LRange. You're taking on the duty of putting in place the surfaces and the parameters of interest. And so I provide an example application, and then if you mirror the files that are used in that application, the spatial surfaces and such, then things should work okay. There are example parameter sets where you can build your own set and modify the simulation until you're content with the results. An application then would need to be adjusted to match the observed responses and assessed. And so prior to using an application in discovery, prior to using it to address scientific questions, the application would need to be assessed to be able to say with some confidence that it's representing reality sufficient to be able to be used to address your questions. And whatever sufficient might be in that case is for you to decide. There's potential to connect to other models, other tools, as I've spoken of. Of course, that's true for any of the tools. Any can be edited to join with other modeling tools and what have you. But here I'm speaking of software available now. So LRange has been edited. Now, again, this is a separate program. It's not part of LRange at its base offering, but another version of LRange has been edited to provide 8 biomass pools that report how much biomass is available as green herbaceous biomass, dead herbaceous biomass, green shrubs, dead shrubs, branches, fine branches for shrubs in the same groups for trees, and then the livestock that would be represented in an agent-based model feed on those biomass pools. The proportion of offtake then is reported back to LRange, and then it tracks from there the offtake and such. Lastly is AFRange, which is an effort on my part to apply the LRange model to all of Africa, and then to have in place an application that people can use directly where I've assessed it as well as I could given time and resources available so that people might be able to use it more or less directly as an experimental platform to address questions of interest to them. And so LRange then is applied to Africa, and as I say, it's got the surfaces in place, much more current surfaces at 20 kilometers and 10 kilometers resolution. The landscape units, whereas in the global application there were 15 for the whole world, here there are 47 for the continent. There are herbivores represented in this application. They can be disabled, of course, but right now every cell has a population of cattle, goats, sheep, camels, donkeys, a mixed wildlife group, and a grazing wildlife group. And the application, as I say, is in place. It can be downloaded and used directly and has been assessed with a report associated with that.